Salam sejahtera everyone. My name is Charles Michael Albert. My participant ID is CT-00036. My institution is University Malaysia Sabah. I will be presenting my research paper entitled Contact Angles of Viscoelastic Thermal Compression VTC Modified Paracerantes Falcateria Laminas. Introduction. Wettability is a molecular interaction which involves direct contact between liquid and solid surface. Contact angle measurement is a method of determining wettability of adhesives and bonding strength when applied to substrates. Paracerantes falcateria is generally known as batai, which has average density of 360 kg per meter cubic. Viscoelastic thermal compression, or VTC, is a densification method consisted of pre-steaming and compression via hot pressing. Materials and method. The raw material used in the study was Paracerantes falcateria with size of 300 mm in length, 50 mm in width, and 20 mm in thickness. These laminas underwent viscoelastic thermal compression (VTC), which consisted of 4 different free-steaming durations. The first parameter is NS/D, which indicated no free-steaming, which was also the control. The second parameter is S1/D, which indicated 10 minutes of pre-steaming. The third parameter is S2/D, which indicated 20 minutes of pre-steaming, and the fourth parameter is S3/D, which indicated 30 minutes of pre-steaming. The hot pressing setting was 105 degrees Celsius for pressing temperature, 6 MPa for pressing pressure, and 2300 seconds for pressing duration. These were the procedures in this study. First process was pre-steaming. The laminas were pre-steamed by using steamer machine. Second process was compression. The pre-steamed laminas were hot pressed by using hot press machine. The third process was cell lumen area test, whereby basic morphology feature of the laminas, which was the lumens, was observed by using scanning electron microscopy (SEM). The fourth process was the contact angle measurement, which conducted in order to determine wettability of the VTC modified laminas. In terms of density, VTC was proven to significantly improve density of Paracerantes falcateria laminas. The final size of VTC modified laminas were 300 mm in length, 50 mm in width, and 10 mm in thickness. Table 1 shows the density mean value of VTC modified laminas. Density of these laminas were improved in range of 600 kg per meter cubic from initial density of 360 kg per meter cubic. For contact angle measurement, ASTM D73340 was used. The main apparatus were appended microliter pipette, phone camera with 4000 × 3000 resolution, and tripod. Water was used as testing liquid. The image was taken immediately when the liquid drop reached the solid surface, which was 0 seconds, followed by 10, 20 and 30 seconds in order to observe changes of contact angle within that specific time period. The images were further processed by using low-bound axisymmetric drop shape analysis plugin in ImageGeo software in order to determine the contact angle values. Results. Area of cell lumen was shown in Table 2 and Figure 2. Figure 2 shows the scanning electron microscopy (SEM) images with 800 times magnification. The mean value of cell lumen area shown in Table 2 indicated that NS/D had the highest cell lumen area of 136.446 micrometers square, while S3/D recorded the lowest value, which was 39.962 micrometers square. In the figure 2, A is indicated for NS/D, V is for S1/D, C is for S2/D, and D is for S3/D. Result of contact angle measurement shown both in Table 3 and Figure 3 indicated that contact angle of S1/D was significantly reduced within 30 seconds, while contact angle of S3/D only shown significant changes of contact angle values from 0 seconds to 10 seconds, and did not have significant changes of contact angle degree afterwards until the 30 seconds. Discussion. The result of cell lumens area and contact angle measurement of VTC modified laminas were influenced by the absence of steam at high temperature inside the wood, which means the wood was not softened, hence reduced the compressibility of the lamina. This also increased the hydrophilicity of the wood as well as the wettability of wood, whereby water tends to diffuse inside capillary of wood. This explains why NS/D, which was non-pristine, had the highest mean value of cell lumen area and had good wettability. It is because cell lumen of NS/D were not completely collapsed or only partially collapsed. Moreover, the result proved that increasing pre-steaming duration, by which 10 until 30 minutes, would enhance the compressibility of the wood. This explains why the mean value of the cell lumen area decreased consecutively according to the pre-steaming duration. However, the significant differences of contact angle between parameters might be influenced by presence of extract tips inside the wood. Previous studies suggested that the presence of extract tips reduced the wettability of wood as well as its adhesion properties. Theoretically, S1/D might have lesser amount of extract tips compared to the other parameters, which cause it to have better wettability. Conclusion. In a nutshell, viscoelastic thermal compression (VTC) enhanced the densities and reduced the wettability of Paracerantes falcataria laminas. Higher pre-steaming duration was proven to influence the compressibility as well as hydrophobicity of the laminas. Poor wettability is an indicator of inefficient adhesion properties, by which will affect the bonding strength for further product manufacturing process. Acknowledgement. The authors would like to express their appreciation to University Malaysia Sabah for their financial contribution to this study through GUG 03131/2019. A special thanks goes to Sapulut Forest Development Sdn Bhd for the supply of laminas. This is the references list that I use. Thank you for listening. Have a good day.